Hi everyone, so welcome back to my channel and let's just start with today's Leetcode challenge, that is minimum number of removals to make mountain array. Till now we have completed 17 challenges. In case you have missed any, you can watch it on my YouTube channel. I've created a playlist for the same. So let's just quickly start with the problem statement. You may recall that an array ARR is a mountain array if and only if array.length is greater than 3 and there exists some index I. It is a zero index with I should be in the range of 0 to array dot length minus 1 such that I this is I minus 1 till 0. So all the values on the left should be smaller than this array of I and all the values on the right should also be smaller than the array of I. Okay, because it is decreasing. So it is also decreasing here. Okay, so we are given an integer array nums and we have to return the minimum number of elements to remove to make the nums a mountain array, right? Now if we go to the example, we have nums 131. In this we have to remove 0 elements because it is already a mountain array, because 3 is an peak point and from 3 on the left side it is smaller and on the right side it is also smaller. Okay, so we will discuss example 2 in the intuition building part. So let's just go over there. Okay, so we can quickly start with this example. We have this array. If you see that it is given array length should be greater than equals to 3 minimum, right? So if you we can see directly that if we start from here we cannot have our mountain. At least we should start from here so that one element should be on the left side and at max we can have any. And similarly, if you want to create a mountain, at least one element should be here and at least one element should be here for getting a peak. So we can start from here and we can in this range we have to get some peak element so that these elements should be like smaller than that. So if we start from here, 2 is smaller, no, so it could not be a peak element. For 1, if you have like any small values on its left, no. For 5, if you see, yes, because 1 and 2 both are smaller on it, so we can pick any. So we can write it like this. We have 5 here and on its left. So let's just create a small histogram type thing. Okay, so let's just say 2 is here, 1 is here, 1 is here, then 5 is here, 6 is here, right? Now we directly jump to 2. Now it is jump to 3 and it is jump to 1, right? This is 3. If you see what is the biggest mountain that you can have, if you see this can be your one of the biggest mountain, right? So it is like 2, 5, 6 and 3, 1. So we can write it here. So 2, 5, 6, 3, 1. So it can be your one mountain. Now if you see how many elements you have taken in the mountain, 5 and total elements are 8. So how many removals you have to do? 3. So let's just say minimum for now we have to remove 3. Now if you try picking this one, so what is the biggest mountain that you can have? 1, 5, 6 and again 6, 3, 1 or 6, 2, 1, right? Anything can be possible. So similarly in this case it can be 2, 5, 6, 2, 1, right? So same both of them. Now again 3 will be minimum removal, and if we try picking 1, then 1, 5, 6 and again 3, 1 can be, and 1, 5, 6, 2, 1 can be possible, right? So what we are seeing, what is the peak element we have? We have a peak element as 6, and for 6 what we are searching for, the decreasing sequence here and similarly the decreasing sequence here. Now what we are getting from this intuition, that if we try making our sequence from the start till we reach a peak element, and from there if we get again a decreasing sequence or the sequence that is again increasing sequence from the last. Okay, increasing sequence as in if you are seeing we have to get the decreasing elements. if this is a decreasing order, then reverse will be increasing. So if you try doing that, increasing from here and increasing from here, and if you get at any value, that will give you maximum size of this, like these three elements here, three elements here. Okay, so size will be total 6. Okay, no, size will be total 5, because 1 5 6 will be 1, 1 3 6 will be 1, 6 is counted twice, so the total size will be 5, right? And after you get your maximum size mountain, you will just have to remove that from the total size, so that you can get the minimum removals. So that will be the intuition. You just need to analyze how you should like get your this sequence. What is it? This is an increasing sequence. It is not a sub array, it is a sequence, because what you can do, 2 5 6, you are removing 1 and 1 both, or if you pick this one, if you pick this one, so it will be this one, 5 and 6 you are removing, so it is not sub array, it is a subsequence, right? And we are seeing that it is increasing, so increasing subsequence, right? And what we are trying to do, we are trying to increase this max to make it maximum. So how we can achieve maximum? If we try finding a longest increasing subsequence, right? Yes, so it is LIS. If we try finding this LIS on left side, similarly this will be a reverse LIS, right? Because we need to find decreasing order maximum length, and if we try reversing it, it will be again LIS to reach this peak element, and it is a reverse LIS, right? And for any index, let's just say this index, if we have our longest subsequence here length and maximum here, so we just get our maximum value and we will subtract it from the array length to get our minimum number of removals, right? So the intuition that we have developed is you don't have to directly jump to the question, a problem statement. You should analyze like how you should how you can get your answer, because if you try doing this minimum, you will try how to remove this, how to remove this and anything. But if you change this problem statement, like this is a minimum removal, if you say max size mountain array, right, then you can directly get the intuition of LIS. But since the problem statement is changed, minimum number of removal, so you like sometimes you get confused. So that's why you need to analyze the statement and don't go over the question statement like every time. So this will be the approach, and you know that LIS we can do it directly. Okay, so how we will do it? First I will take this example again. Okay, so now we will like try finding, we will create two arrays. So it will be, first we have to do left, this will be a left LIS, and this is reverse, so it will be a right LIS. Okay, so left LIS and right LIS, this should be again same size, now again similar 8 size, right? Now we will, for the left we try finding from the left side, and from right we'll try finding from here. Okay, since you know that we have discussed in the first part that we will start finding our LIS from here and I'll reverse LIS from here. So for the first, what is the minimum left the LIS? It will be of one size, because it will include only 2. Now for this one, again same, because it is not an increasing subsequence, right? So again one size. For this one, again 1. Now for this 5, you can have either 1 5, this 1 5 or 2 5, anything will work, so it will be of 2 size. So in this LIS we are storing the longest increasing subsequence size, okay, for both of them. So till 6, what is the maximum size that of LIS that you can get? It can be 2 5 6, 1 5 6, anything that we have discussed here. Okay, till 6 it is 3 size. Okay, so now for this 2, if you see that including this 2, what is the maximum size of the LIS? It is 1, 2, because at max you can pick 1, 2, so it will be of 2 size. Similarly, at this 3, what is the maximum size of LIS including this 3? It will be 1, 2, 3. For this one, this 2 and this 3, so it will be 3, right? And for this one, we see directly, it will be of 1 size, because including this one, there is no subsequence more than 1 size because it is the smallest. Now if we try populating the right LIS, so we will start from the left side, right side. Now again for this one size, including this 3, it will be 2 size, including this 2, so maximum it can have these 2, so again 2 size, including this 6, 1, 2, 6 or 1, 3, 6, anything will be possible, it will be 3 size. Now add this 5, 1, 2, 5, 1, 3, 5, okay, so it will be again 3 size. Now add this 1, including this 1, so it will be 1 size only. Similarly for this one, it will be 1 size, and for this 2, 1, 2 will be maximum, or this 1, 2, any 1, 2 will be, so maximum it will be 2 size. Now what we have discussed, that if you want to have maximum size of the mountain, so what we have to calculate, like the mountain is like this, right? So one element, one element, one element, and this is your left LIS. So left LIS is size 2, and your right LIS is RLIS is again 2. So the mountain length is 3. So 2 plus 2 minus 1. So this will give your answer. So what you try to do, for every index, try maximizing total length, right? Total length of mountain, because you need to maximize your mountain so that the removal will automatically be minimums. Now you will go to each index, and what you have to maximize, your this sum minus 1. So left LIS of ith plus right LIS of ith minus 1. We need to maximize this. Now let's just maximize. For this, it will be 2 plus 1, 3 minus 1, 2. For this, 1 plus 1 is 2, minus 1, 1. 1 plus 1, 2, again minus 1, 1. 3 plus 2, 5, minus 1, 4. 3 plus 3, 6, minus 1, 5. 2 plus 2, 4, minus 1, 3. 3 plus 2, 5, minus 1, that is 4. 1 plus 1, 2, minus 1, 1. So for this one, what is your length? How you can do it? 1, because this is the smallest, and including this 5, what is your size of the mountain? Is 4. How it is possible? So if you try doing it, because if you see left LIS is 2 size, so it is 1, 5, right? Now right LIS is 3 size. What is it? 5, 2, 1, and your length is coming out to be 4. So we are going right. Now we have all the lengths, right? What we have to pick? Maximum. So maximum will be this one. Now we just have to subtract it from size of array, that is n minus 5. So 8 minus 5 is 3. We already got our minimum answer. That is a correct. So this will be the approach. And now the time complexity thing. So this LIS we are finding, this will be taking direct ON square. This will be taking again ON square, because these will be calculated with 2 loops. Now when we are finding this maximum, it will be big of n, right? So the total complexity big of n square plus big of n square plus big of n, right? And it will be around n square only, and space complexity will be big of n. Since we are using these 2 arrays, it will be big of n, so that accumulates to n, and we can possibly say big of n. Now we will move to the coding part to get the better understanding of this approach. Okay, so we can quickly start with the solution part. So first we will get our size. So nums dot size. Now we will create our 2 LIS. So vector int left LIS, it will be of size n, and minimum it should have one value at least, because for each element LIS size will be 1 at least. Now we will go for this populating left LIS. Now we will populate left LIS. So we'll start from first as we have discussed and going till this second last. So it will be n minus 1, right? So now we will, how we will populate? Let's just take one variable. So int max, int mx, it will be 0. But we will calculate how. So if we are at ith element, we will try finding maximum value of our LIS on its left side, and then including this, what will be the maximum? Including this, it will be like 1 plus what is the maximum value on its left. So now we will go for int j 0 till I. Okay, before this 5, now j plus plus. What we will capture if your nums of ith value is greater than nums of j, right? If this ith value is greater than this 2, right? Yes. Now we will do our operation. So we will populate, our maximum size will be maximum of previous maximum size, or your what is present in the LIS. Okay, it will be left LIS at your jth position, because j is now traversing from this 2 till 1. So j, when we come out of this loop, what we have, maximum length of the LIS on its left side for 5, and for 5 now how will populate? So left LIS of ith will be equals to 1 plus your mx, right? We are going right. So for this 6, how it will capture? For 5 it will already populate 2, because 1 is this, and including this it will have 2. So 5, for 5 it will have 2. Now when 6 will be populated, so 2 to 5 will be like traversed, and when it comes to 5, maximum will be populated with 2. So at 6, including 6, it will populate 3. So we will get our answer as per our intuition. Now we will do the same for right, and how we will traverse? Now we will traverse from reverse direction, n minus 2 and I greater than 0 and I minus minus. And similarly our mx will be 0. Now we will update this loop logic. So how we will, for 6, how we will calculate? We will go on this loop. So I will be here. Now j will start from I and go till n, till last element, right? And what it will try to check, same check will be there. Nums of I should be greater than nums of j. We will update this and it will be now updated to right LIS. So we have our answer in left and right. Now we will find our int total max size of mountain. Okay, so this will be currently, let's just say 0 we have assigned, and now we will go for int I 0 till n I plus plus. What we will capture? We will int total will be left LIS of I plus right LIS of I minus 1, right? So this will be total length. Now we will update this total. So it will be maximum of previous value, okay, and it will now get the this total. So this is how we will update our total max size mountain, and similarly we will return this. Okay, sorry, so we will not return directly. So this is the maximum that we will get. It will be 5. So we have to subtract it from the length. So this is the minimum number of removals we will get. There is one constraint that we have seen earlier. So array.length should be 3. but greater than equals to 3. So this what it means, that minimum mountain length should be 3. And in case, because we have seen some cases where this is 1 and this is 1, so the answer that we are getting is 1 only, because 2 1 plus 1 is 2 minus 1 is 1, and we will get this total max size mountain as 1. So that should not be the case. So we will, before doing this, we will directly check if left LIS of I is greater than 1, right? Then only you can get, because if this is 1, this is 1, then you will get your 1 plus 1 2 minus 1, that will be 1 size only. And right LIS should be greater than 1. If this is right, then we will get our max size mountain. Now we will get our answer, and let's just try to run it. Right now we will try submitting it. Okay, so we are getting wrong. Let's just check why. For this we are getting answer as 2. Okay, so let's just check the logic. So we have this 1 till n minus 1, so it will go till n minus 2, and now we will go from 0 to I minus 1. We will populate the ith value with 1 plus mx. Similarly, n minus 2 will go till this, and j will be till I. Okay, should start from I plus 1, right? Because ith will be populated with 1 plus, and it will go till this, right? Okay, so I think where are we missing? So I think yes, here. So we are populating right, but we are doing it for left. So this is how we can do. Let's just try again running it. Okay, so we have got the answer right. Now we try submitting it. Yeah, so we have submitted this successfully. Thanks everyone for watching. In case you do like this video, please do hit that subscribe button and turn on the notifications. And if you have any questions or any doubts, please do ask in the comment section. I will try to answer all of them. And thanks everyone.